Hi, Algebra 1 friends. I thought we'd be able to get through 3 sections in one video, but that's okay. We're on section 12.8, and we just finished up sections 12.6 and 12.7, and I think you should just watch this straight through because it's kind of related to what we've done before. So here, we're looking at adding, or in this case, adding a mixed expression. So we've got a whole number and this rational expression. And so what I would do in this case is treat that 3 as a fraction and then follow along with the system that we had developed in the last section. So what we know is when we want to add fractions, we need a common denominator. And so that's what we're looking for. The common denominator has to have x plus 3 in it, and 1 is already included. Therefore, x plus 3 needs to be the denominator for both. 6 will be the numerator here because nothing has changed, but the numerator on this side is going to be 3 times x plus 3. In a sense, if you look at it, we're kind of multiplying 3 by a special 1. That 1 is x plus 3 over x plus 3. This concept of multiplying by a special 1 is going to be with us throughout this section, so please stay focused on that. So watch this. So now that we've got a common denominator, x plus 3, my numerator is going to be 3x plus 9. You see what I did? I did a little distributive property, plus 6. And I'm going to join like terms together and hopefully be done with this. 9 plus 6 is 15. So I'm done. I could factor out the 3 just to see if I have anything that's going to cancel. I don't, but kind of good practice to make sure we can see what factors we have when we're done. And that's it. That's it for this particular type of problem. Let's look at this next one. Actually, I'm going to skip this one because it has some information that I didn't copy, but let's look at this next one. So complex fractions involving monomials. This looks crazy, right? This looks really uncomfortable. I'm going to rewrite it because I think I copied it and it wasn't as clear. So we've got x squared times y squared over a over x squared times y over a cubed. So this is going to be a great situation where I like to talk about bringing out my big number 1, okay? So the number 1 I'm going to use is the one that's going to eradicate the denominators of both of these. So watch this. I'm going to choose a to the third power over a to the third power. I just think it being so large, it needs a deeper voice. So that's where I'm going with. So a to the third power over a to the third power is what I'm going to multiply the numerator by and the denominator by, okay? So watch what happens. In the numerator, I get the a's cancel, and I end up with a squared, x squared, y squared. Did you see that? Whoosh, whoosh. Sorry for the sound effects. I feel like it's thrilling, but maybe not. So I get a squared, x squared, y squared right there. You see the little cancellation. And the same thing's going to happen here, except boom, boom, cancels each other out, and we're left with x squared y. Well, this is so much more doable. We're not done. I shouldn't have circled it. But this is so much more doable than that thing over there. So I'm going to look at a different way of talking about it, but sometimes I like just call it knocking it out with a big old 1, okay? So now we can cancel these bad boys out, cancel these bad boys out, and we end up with a squared. No, we don't. We end up with a squared y because this is just 1 and that's a 2. Thank you for being patient with me. So we end up with a squared y. Let's look back over here and see how we could have handled this. So really, when I have x squared y squared over a divided by, right, x squared y over a cubed, you can literally treat this like we did with our division of rational expressions where we change it to multiplication. We flipped it, we did that, and then now you can have your canceling party. Tra, tra. Sorry, just more sound effects every time. And then we get this, and then here we get the a squared y. Why did I do it in this big 1 way? Because this is sometimes going to be helpful when you can't see your way out of a situation like this. Both ways are acceptable. This method and this method, both totally fine. Feel free to use either. I do want you to practice using a large 1 when we get started with this. All right, so over here we have another ridiculous looking problem, but we can handle this one too. I'm going to handle this with a large 1. Can you guess what my large 1's numerator and denominator will be? It's going to be this denominator here. It's going to be a minus 2. So what I'm going to do is multiply each term by a minus 2. So I have kind of a regular looking rational expression. So a minus 2 times a is going to be a times a minus 2. A minus 2 times 15 over a minus 2 is going to be a minus 15. Why? Because the a minus 2's canceled here when I multiplied it by the 15 over a minus 2. So this is starting to look a little bit normal. I don't have the complex fraction situation. Then I have a plus 3 times a minus 2 here. And so I can't cancel these out, which is totally tempting because I can't cancel out that which is not strictly being multiplied by everything in the numerator. But I can multiply through and see if something good happens. Maybe I'll get to factor. So when I multiply the numerator, multiply through with the numerator, I get a squared minus 2a minus 15. Still going to leave this factored because maybe I can factor the numerator and something good will happen, meaning I'll get to cancel something out. When I try to factor the numerator, I get minus 5 and a plus 3. And that's from me trying to figure out two numbers that multiply to give me negative 15, yet add up to give me a negative 2. A plus 3, my bad. So a plus 3 here and an a minus 2 here. Swoop delicious, I did get to cancel. And I get a minus 5 over a minus 2. Look at this over. Look at how we did this. I know it seems weird. This 1, this is really the number 1, but I chose a specific number 1 for my situation to alleviate me of this denominator. And then I had to literally distribute the a minus 2 to each of these. And I'm looking at this a minus 2 as a unit. And I know that's not the way we usually do things. We usually think about foiling it, doing a squared times a, and then doing the 2. But you can look at this whole thing and multiply it by each term. That's totally legitimate, and it really is equivalent to our foiling things out. All right? Okay, let's go ahead and look at one more example. No more examples. Oh man, the fun has ended. That's okay. Hopefully this makes sense. We'll talk about this before you do a whole lot on your own, all right? Take it easy, guys. I look forward to seeing you very, very soon. Bye-bye.